Once the depth of the flowing layer has been determined, it's necessary to ensure that the channeling screens are at least as deep as this depth. Usually a safety margin of 0.1 of a metre is added. If the balcony or ceiling measures less than 1.5 metres from the opening to the spill edge, then smoke will usually have sufficient forward impetus so as not to require channeling screens. If this is the case, and there are none provided, then it is assumed that the smoke will expand sideways a little as it flows towards the spill edge. The extent of sideways expansion is assumed to be equal to the distance from the opening to the spill edge, and this is known as WB. So if we have an opening 5 metres wide, and the distance from the opening to the spill edge is 0.9 of a metre, we take the width of the spill plume at the spill edge to be the 5 metres of the opening width plus the 0.9 of a metre of the distance from the opening to the spill edge. So that's 5 plus 0.9, which equals 5.9 metres. The depth is, of course, of little importance in this case, as we're not providing channeling screens. BS 7346 Part 4 gives a discussion about the amount of heat that might be carried in the smoke as it leaves the room of fire origin. If you recall, for axisymmetric fires, we assumed a value of chi of between 0.67 and 0.8. This was the fraction of the total heat output that was given out as convective heat. In the complex plume scenario, there is the opportunity for heat to be removed from the smoke as it travels through the building before rising into the atrium. Before the smoke leaves the room of fire origin, by the opening, it may have lost considerable quantities of heat due to it passing over cold building surfaces or by the action of sprinkler water. If the fire starts at the back of a room of fire origin, then a lot of heat may have been removed from the smoke before it leaves the opening, but if the fire starts near the opening, then very little heat may have left the smoke before it leaves the opening. As we don't normally know where the fire is likely to be in the room of origin, there is an argument for varying the value of chi to assess the ventilation requirements under the varying conditions. But often, however, in practice, only one value is used for chi. The figures given by BS 7346 Part 4 for possible values of chi are 0.25 for a sprinklered building if the fire is far from the opening, and 0.5 for an unsprinkled building if the fire is far from the opening. However, usually we do not know where the fire might be in the room of origin, so only when it has been demonstrated that the fire can only occur some distance away from the opening would it be desirable to use these reduced values of chi. It is more normal just to assume the value of chi of 0.67 or 0.8 or some intermediate value, as we have done earlier in this course. So far, we've been considering that the smoke is going to be allowed to spill into a centralised smoke reservoir to be exhausted from there. It may be, however, that it is desirable to extract the smoke beneath the balcony or the ceiling so that it does not spill up into the smoke reservoir. In effect, the area under the ceiling or balcony becomes a small reservoir itself. To achieve this, it's necessary to contain the smoke by means of screens around the perimeter of the small reservoir that is created. This under-balcony extraction has the advantage that it limits smoke damage and facilitates a quicker and easier return to normal working conditions. Also, this form of extraction is essential where the height of rise of a potential spill plume would be so great that the prediction of the amount of smoke produced becomes excessive and unreliable. It is, however, likely to be more expensive, as much fire-rated ductwork will be required and mechanical extraction will be essential. If it's desired that the smoke is contained under the balcony, then containment screens will be required all around the area we want to restrict smoke to. We've already seen how to calculate the depth of the flowing layer outside the opening, and this gives a base figure for the required depth of these screens. Where the smoke layer meets a transverse barrier, it will deepen locally against this barrier as it is stopped by it. So if the void edge is close to the fire, then this local deepening could be large enough to cause smoke to spill beneath the smoke curtain and to flow up through the void, possibly affecting escape routes. Therefore, the barrier needs to be deep enough to contain not only the established flowing layer depth, but also the additional deepening that takes place as the smoke meets the barrier. This is a formula that's used to determine the extent of local deepening. Delta dB is the amount of additional deepening in metres. HS is the height of the underside of the ceiling above the fire base, dB is the depth of the flowing layer. WB is the distance from the opening to the transverse barrier that contains the flow. When the additional deepening has been determined, the depth of the containment screens can be set by adding together the flowing layer depth and the additional deepening given by this formula. None of the published guidance gives recommendations about a safety margin in this case, but a small margin should be considered a good feature. Now David's going to do some examples looking at required depth of containment screens.